What's up, guys? It's your boy Kennedy here with another episode of Quarantined Math. We're going to go over our Unit 2 quiz that you missed because you got too close to COVID. Before we get started, make sure you go and like and subscribe to my YouTube channel or you're going to get bad luck for the next 29 years of your life. If you do like and subscribe, your crush will text you in the next 48 hours. Whoa! I'm got a little bit of energy right now because I'm drinking the brand new pineapple bubbly. No big deal. So things are going good in this household. Hope they're going good in your household too. All right, this quiz. I'm going to go decently quick so you can kind of skip through to the questions that maybe you want to see. Plus, there's a lot of them. There's 15 of them, so it would take a lot of time. Question number 1. When factored, which is a factor of 0.5x squared minus 3x plus 2.5? Okay, first thing I need to recognize is that I need to factor. Yeah, when factored. Second thing I need to recognize is there's decimals, and decimals scare me because I'm easily afraid of many things. So I want to get rid of those decimals. Best way to get rid of decimals is to multiply the entire equation by something. In this case, because my decimal is 0.5, the best thing I can do is multiply by 2. So I'm going to go ahead and I'm going to multiply everything by 2. And that turns my equation into x squared minus 6x plus 5. Now remember, technically, when we multiplied everything by 2, we have to balance that out somehow. We balance that out by putting a 1 over 2 out front. So yeah, I multiplied by 2, but then I also am multiplying by 1 over 2, so it cancels itself out. Awesome. That blue thing, you can now diamond method factor. So I go to diamond method factor that. I need things that multiply by 5 and add to be negative 6. That'd be negative 5 and negative 1. That means my equation is now x minus 5, x minus 1. Take a quick peek over here. X minus 1 is my answer. There is my factor, x minus 1. Easy money to start the question. Start the test, not the question. Question number 2. Factor this polynomial expression. If I look at that, that looks terrifying. Main reason it looks terrifying is I have this, like a binomial squared, and I have this, another binomial squared. And that means I'm going to have to do a lot of expansion, which is going to turn into a lot of mayhem that I don't really want to deal with. So when I see something like that, what I'm going to try to recognize is that I can replace binomials with letters. I could say instead of 2x minus 1, we're going to call that m. And instead of y plus 2, we're going to call that n. And then I can actually replace these with just single letters. By doing that, it turns into this equation. 16m squared minus 9n squared. That is a much better question to factor. That is a difference of squares. I can square root both things. Remember, that'll give me 4m minus 3n. That's only my first binomial. My second binomial is the conjugate. It's the exact same thing with a different symbol in the middle. So by taking that original question, changing the binomials into single letters, it becomes a question that is much easier to factor and manage. Now, though, I need to go back to this question and I need to change my letters back into what they used to be. So instead of m, I need to put 2x minus 1. Notice that I'm using square brackets to do this. That's going to help me kind of keep my work organized here. Instead of n, I'm going to go square bracket y plus 2. Sorry, I'm writing kind of small. I hope that you're watching on a big screen TV. Maybe you got me playing in your movie theater or something, really get a good vision of math here. It's going to be 2x minus 1. Oh, I'm running out of space already. I got to write small. Plus 3. Y plus 2. Oh, yeah, just squeezed it in there. Just made it. Okay, the reason why I was so adamant in using square brackets to make that next substitution is it's very easy for me to tell which brackets go with where now, right? My round brackets, it's pretty clear to tell where they are. My square brackets, it's clear to tell where they are. My goal is to simplify inside the round brackets. So I need to get rid of the square brackets by multiplying these numbers in. When you multiply in, make sure you're multiplying -3 into the brackets on this one. The other ones aren't quite as complex. When you do that, you should end up with 8x minus 4 minus 3y minus 6. And the other one would be 8x minus 4 plus 3y plus 6. And you'll see that inside your round brackets, you have some like terms that can go together. So like this first one turns into 8x minus 3y minus 10. This other one, if we look at our like terms, will become 8x plus 3y plus 2. We take a quick peek to see where our answer matches up. Looks like it matches up with D. So your answer for that one would have been D. Awesome. Those first two questions are kind of our hard 20-1 level factoring. We have one with fractions or decimals that we have to get rid of. We have one where we have to change a binomial to a letter. Awesome. That does it for the high level factoring questions. We're now going to move on to some solving questions. So we're going to look at number 3. It says, which statement is true for the equation x equals 6x plus 7? It's every answer, if I look, it says something are roots. Roots are solutions. So when it says 7 and -1 are roots, what it really means is that 7 and -1 are solutions. To tell if something is a solution, all you need to do is take this number and substitute it into the equation. So put it in for x and see if it actually works out. So if I put the number 7 in for x, I get 7 equals the square root of 6 times 7 plus 7. I don't know why I put a bracket there. This pineapple bubbly's got me going, I guess. You can then put that into your calculator, right? So the left side's obviously still just 7. The right side ends up being the square root of 49, which is 7. Both sides equal each other. That means 7 is a solution. Awesome. The second part is that -1 is a solution. Well, put -1 into the original question and see if it works out. When I put -1 into the original question, I get 6 times -1 plus 7. That gives me -1 on the left side. On the right side, I get the square root of 1, which equals 1. Notice that one of them is negative, one of them is positive. That means -1 did not work. In fact, it is an extraneous solution. So the answer to this question would be B. 7 is a root. It worked out. And -1 is not a root. It turns out it's an extraneous root. Really, I can get my answer because I know 7 is a root. It is a solution, and none of the other answers suggest that. So that's how I know B is right. All right. Number 4. Number 4 is a question that people do too much work on. We overwork this question. The reason why is because they look at it, they see, oh, that's a quadratic, but I need to expand it. Reality is you don't need to expand it. This question is already factored, and it already equals 0. This means I can already use the zero product property. I have something times something equals 0. So if I just check, I can tell what would make the entire equation equal 0 if I could tell what makes each set of brackets equal 0. This one would be 1, because 1 minus 1 is 0, and 0 times anything would still be 0. And this one is positive 5 over 4, making our answer B. So that question was already factored for you. It was already set up for you just to like quickly check your zero product property. What makes each binomial equal 0? Alrighty then, number 5, solve this equation. To solve an equation, I need to get rid of that square root sign. So what I'm going to do is I'm going to square both sides. When I square both sides, remember that 2x is in brackets. So that squared is going to come into both things. That means I now have 4x squared equals 12 minus 8x. So I got rid of my root sign. That looks like something I can actually manage now. I want to solve that quadratic. Solving quadratics means you have to equal 0. So I'm going to move my numbers over to the left by adding 8x to both sides and subtracting 12 to both sides. This gives me 4x squared plus 8x minus 12 equals 0. Now that I have a quadratic equals 0, I have many ways to solve this. I could factor it, I could use quad formula, or I could use box method. I'm going to choose to factor it because that's my favorite method. And I'm also going to recognize to take a GCF of 4 out. That'll make my factoring much easier because now it's numbers that are quite simple to work with. If I want to factor that thing, I do a diamond. Things that multiply to be negative 3 and add to be 2. It would be 3 and negative 1. That means this factors to be x plus 3, x minus 1 equals 0. That means my solutions are x equals negative 3, x equals positive 1. Now, if you look, the solutions, like one of them says x equals negative 3 only, B says x equals positive 1 only, and then D has both my answers there. Remember that after you get a solution and you algebraically find an answer, you need to test those answers because sometimes one of them won't work and it's extraneous. For instance, take x equals negative 3, substitute it into this original question. That would give you 2 times negative 3 equals 12 minus 8 times negative 3. That means I have 6 on the negative 6 on the left side equals, if you put this whole thing in your calculator, it equals positive 6. Those do not equal each other. One is negative, one is positive. Therefore, negative 3 is an extraneous solution. It does not work. And the correct answer is x equals 1. Negative 6 ends up being an extraneous solution. Fantastic. Number 6. The solution to the equation, they give you the equation, can be written in the form a plus or minus root b. The value of a plus b is. All right, this question. Also another one where people like over-calculate what's going on here. What I want to recognize is this is essentially what I get after I do the box method. Notice that I have a binomial squared and then all constants. That means I can solve this thing by just square rooting both sides. But before I can square root both sides, I need to move that 7 over so that it is isolated. If you listen carefully, you can hear the feet of my wife walking around the house. She's just getting a snack. Do you want to say hi?